Thanks for watching this help video for the Unit 3, Lesson 3 functions. So the first one says, find the next three terms in the sequence. So 33, 26, 19. In order to find the next three terms, we have to figure out either what is the common difference, if it's adding or subtracting the same number every time, or what is the common ratio. My computer is freezing up. So we have to figure out how they're getting from one number to the other. So if you don't automatically see it, I suggest you check both. So on this one, I'm going to check for the common difference and the common ratio. I'm going to start with the common difference. Now remember, difference in math means subtract. So you're going to start at the last number you have and you're going to subtract. So I'm going to do 19 minus 26 in my calculator. And then I'm going to keep going. So 26 minus 33. And I'm going to see if that equals the same number every time. So let's go do that in Desmos. 19 minus 26 is negative 7. Let me put that down. Oops, wrong one. Just kidding. And then 26 minus 33. Where did I put Desmos? There it is. 26 minus 33. That's also negative 7. So this does have a common difference. We are subtracting 7 every time. And you can double check it by doing 33 minus 7, and it does equal 26. And then 26 minus 7 does equal 19. So to get my next term, I would simply subtract 7 again. So I'm going to do 19 minus 7. Which is 12. And then I'm going to do 12 minus 7. Oops. Excuse me, which is 5. And then I'm going to do 5 minus 7, which is negative 2. So my next three terms would be 12, 5, and negative 2. Okay, so let's look at the next one. It says, write a rule for this sequence. So when we're thinking about a rule, we're basically just saying, what number do you start with, and then what do you do to it every time? In this case, we start with 33, so you would need to mention that. Start with 33. And then what we did every time was we subtracted 7. So then we would just say, then subtract 7 each time. Something like that. You just have to know what the starting number is and then what your common difference is. You have to know what to start with and then what to do. All right, let's look at the next set of questions. Find the first four terms of the sequence represented by the expression. So now we're not given some terms, we're given an actual rule. So in order to use this, we just need to plug in. We want to find the first four terms. So we're going to plug in a 1, a 2, a 3, and a 4. And if you want to make this a t-table, you certainly can. We're plugging these in for n, and then we're seeing what we get. So if we plug a 1 in, we're going to say 2 times 1 minus 3. 2 minus 3 is negative 1. And then for the next one, we would plug in a 2. 2 times 2 minus 3. 4 minus 3 is positive 1. Then we would substitute it. And by the way, I should have highlighted it over here. We're plugging these values in for the letter n. And anytime you plug in numbers into a letter, you have to make sure you use parentheses. So 2 times 3 minus 3, that would be 6 minus 3, which is 3. And then we're substituting in a 4. So 2 times 4 minus 3, 8 minus 3 is 5. So the first four terms would be negative 1, 1, 3, and 5. All right, look at the red lines. For how many minutes did your speed remain constant? If your speed remains constant, that means it's not changing. It's not getting faster and it's not getting slower. And if we think about speed on a graph, faster would be going up and slower would be going down. If we want it to remain constant, we need it to be the same the whole way. So if we look over here, our speed is 4 kilometers per hour for the first, 4 seconds. This is the part I'm looking at. The speed is 4, and it stays 4 all the way through those first 4 minutes. Oh, 4 minutes. That's minutes. Okay. So how many minutes did your speed remain constant? Well, it remained constant for 4 minutes. After that, it increases, you get faster, and then after that, it decreases and you get slower. So the only time it remained constant was right there. The graph shows the amount of gas in the tank of Sharon's car during a trip to her mom's house. At what time did she stop to buy gas? So she starts off with 12 gallons. As she drives, her gallons get lower and lower and lower. She gets down to 4 gallons and she's like, man, I should probably go ahead and fill up. So then she stops right here and she fills her tank all the way back up to 12 gallons. And then she drives some more and so on. So if we want to know the amount of gas in the tank, blah, 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 what time did she stop to buy gas? She stopped right here, which in my situation was at 7 o'clock p.m. Now remember, I did change it from your actual assignment, so make sure you look very closely on yours. All right, which is a table of values for y equals x minus 6? So we basically are going to look at each of these tables and we're going to plug in the numbers for x to see which ones give us the correct numbers for y. So if we go over here and we plug in a -5 for x, so it would look like -5 minus 6. That equals -11. And over here it says it should equal 1. That's not true. So I know that's not my answer. So I'm going to move on to this one. We just said that if we plug in a 5 for x, it equals -11. So this one works, but we got to make sure they all work. So now let's plug in a -8 for x. So -8 minus 6. And -8 minus 6 is actually, what is that? 8, 9, 10, 11, 12, 13, 14. A -14. And so that one's not right. So let's go over here. We know that when we plug in a -5, we get a -11. We know that when we plug in a -8, we get a -14. So let's check the last one. When we plug in a -7 for x, we also get a -13. So this one is all the way correct. That would be our answer. A gas station charges $3.19 per gallon of gas. Use function notation. And by the way, function notation just means you're going to have like f of x or g of x or something like that. So function notation to describe the relationship between the cost, C of g, and the number of gallons, g. So the total cost, C of g, equals $3.19 per gallon. And they said to use G for gallon. So $3.19 per gallon would mean that you were multiplying those together. And I think that's your function rule. And if you just want to know how this function rule works, like if you wanted to know the cost of 2 gallons, you would do 3.19 times 2, which, let's see, that's should be around $6 and something cents. Yeah, $6.38. So the cost of 2 gallons would equal $6.38. Now you don't have to, keep finding all these. I just wanted to just show you how the function rule worked. If you wanted to know the cost of 10 gallons, then you could plug in a 10 wherever you see G, and 3.19 times 10 would be $31.90. So that's just kind of how it works. You don't need to do that. You just need to write the rule. All right, use the function rule f of x equals 3x minus 2 to find the output of f of 2.2. So notice wherever we originally had f of x and now we have 2.2, that means wherever we see the letter x, we want to plug in 2.2. So I'm going to rewrite it. F of 2.2 equals, remember I just plugged it in for x there, and then I'm also going to plug it in for x here. And remember when we plug things in, we put them in parentheses. And now I need to multiply this out. You can use your calculator. So 3 times 2.2 minus 2. Clear all this out. 3 times parentheses 2.2 close parentheses minus 2. That equals 4.6. So f of 2.2 equals 4.6. That is your answer, is 4.6. So any value it gives you, if it had said f of 8, that just means wherever you see that letter x, you have to plug in an 8. So it just tells you what you're plugging in or what you're inputting. But that's not what it asked for, so ignore that. Okay, here we go. Identify the sequence as arithmetic or geometric or neither, and explain your answer. Now remember, arithmetic sequences are when we add or get a common difference. Geometric sequences are when we multiply or get a common ratio. And there are definitely sequences that don't follow either. So let's check out this example right here. I always like to try to find the common difference first, but we can also try to find a common ratio if that does not work. So we start with our last number, 0.2, and we're going to subtract the next one, 0.8, to see what that equals. I shouldn't put an equal sign there. And then we're also going to try 0.8 minus 3.2 to see what that equals. And if they equal the same thing, then we have found a common difference. So let's try it. 0.2 minus 0.8. That's negative 0.6. And then if we do 0.8 minus 3.2, that equals negative 2.4. So they do not have a common difference. Wait, what did that equal? I already forgot. Geez. Negative 2.4. Okay. So if they don't have a common difference, that means it's not arithmetic. We are not adding or subtracting the same number every time. All right, so now let's go over here and try to find the common ratio. Now, ratio is where you make a fraction. So you're going to take your last number, 0.2, you're going to put it on top, and then you're going to divide it by the next number, 0.8. You're going to see what that equals. And then you're going to take 0.8, and you're going to divide it by 3.2 to see what that equals. If they equal the same thing, then we do have a common ratio, which means it would be geometric. So let's try this one. It was 0.2 divided by 0.8. So that one equals 0.25, or you can make it a fraction, which is 1/4. And then let's look at 0.8 divided by 3.2. 0.8 divided by 3.2. That also equals 0.25 or 1/4. So this does have a common ratio, and since it's a ratio, we're going to leave it as a fraction. So the common ratio is 1/4, which means it is geometric. If neither of those had worked, then you would pick neither. What is here? Oh, that's it. All right, good luck on your quiz, guys.